Okay, so question 4, we're starting with the graphs. We have points A and B. A and B are the x-intercepts for the graph. The graph is fx is equal to ax squared plus bx plus c. The y-intercept of the straight line through D and B. Y is the D is the y-intercept of the straight line through D and B. So there's a straight line going through those 2 points, and the straight line's equation is negative 3x plus q. And so the first question is determine the value of q. There's q, and we're trying to determine that value. Let's see. Question 4, we have one parameter left to solve, so substitute a point. So I only want to find this value in this expression, and so to do that I can substitute any point that lies on that graph, and the point is 6, 0. And so once I do that, 6, 0 substituted, I get q is equal to 18. Excellent. So q is equal to 18. Determine the equation of f in the form of ax squared plus bx plus c. Show all calculations. And remember, there's 2 ways of solving the equation of a graph, and a parabola. And that's either when I have the turning point or when I have the roots. When I have the roots, I will use this expression. Perfect, that's the expression you use. And so how do you do it? Well, you substitute the roots in here. So my one root is negative 3, the other root is 6. So it's x minus 3, it's plus 3, and x minus 6. And that's what it gets here, my 2 roots. Because if I make this equal to 0, I should get x minus 3 and x plus 6. So that's why. I keep my a there because I don't know if I've got some sort of coefficient in the front that I took out and divided. And so first part is to get my a. I substitute then. The reason why I'm substituting is 0 here and 18 there is because now I'm trying to solve a. So I've got one parameter left to solve. I've got my x1 and my x2. Now I only have a left. So to solve a, I substitute a point, and substitute the point 0 for x and 18 for y. Now where does he get the point 0, 18? Where does that come from? Well, it's the coordinate for D. I know that q is the y-intercept of the straight line. Okay, and that y-intercept is now negative 16. Positive 18, I mean, sorry. And so that's why in the end we get a is equal to negative 1. When I put in the negative 1 and my values here, I multiply out these two brackets, so I get positive 3, negative 6, so I get negative 3x, negative 18, then multiply in my negative 1, and there is the final answer. Excellent, excellent. The next question is determine the coordinates of the turning point for E, the function of f. Now if I want the turning point, there's actually different ways of doing it. Probably the easiest way, if you have the roots, is just to get the midpoint between the 2 roots. Okay, so 6 plus 3, negative 3 divided by 2. 6 plus negative 3 is a negative 3 divided by 2 is negative a half. But alternatively, you could have used this method where you just use the turning point formula, which is negative b over 2a, and negative b is 3, so it's negative 3 over 2a is 2 times negative, and you see you get 3 over 2, which is also that gives you the x coordinate. Another thing you could have done is you could have just taken the derivative and make it equal to 0, so multiply, so that it becomes negative 2x plus 3 is equal to 0. The plus 3 goes to the other side and gives you negative 3 divided by the negative 2, which gives you 3 over 2 as well. So there's different ways of finding the turning point. My favorite one is to find the derivative equal to 0, because I can just always do it. I can't always use the turning point. I can always use the turning point formula, the method he's using here. I can always use the turning point formula for a parabola, but not for any other graph. Any graph where I want to find a turning point, I can make the derivative equal to 0, because I'm just working out where is the gradient equal to 0. This turning point formula is specifically for ax squared plus bx plus c. Okay. That gives you just the x value though. You have to substitute the x value, and that's what he does here. He substitutes the x value into the original function to get the y value. And so there's the coordinates for the turning point. For which values of k will fx equal to k have two distinct roots? Now, guys, they are going to ask you a question like this. They are going to ask you a question like this. They are going to ask you a question like this. Just get it. Get it now. Okay? And no, I see what he's doing here. He's taking this expression and we want two distinct roots. So we want, it's not the square root of this function we want bigger than 0. We want what's inside to be bigger than 0. But what he's not taking into account is that it's not saying fx equal to 0. So this is not the expression I'm trying to get. There's a equal to an equal to k on this side that we're trying to. So in other words, my c is not just 18, it's 18 minus k. The minus k must come that way. But by far the easiest way of looking at this is saying, well, fx equal to k, k is just a horizontal line, a constant value, a horizontal line. So where will fx equal to k have two distinct roots? Means where will fx, that's my fx, and k is now just a straight line. Okay, and where will that straight line cut 2 times? For what value of that straight line? And it's very easy, because if I make my straight line above the turning point, I won't cut at all. If I make it equal to my turning point, I'll cut once. And if I make it less than my turning point, I'll cut 2 times. So the answer is just less than the turning point. So this is a very common way of asking it, but k is therefore less than that value. So for k less than 80, for k less than 81/4. Okay. That's just the y value of the turning point. 5.2. Calculate EF if EG is perpendicular to the x-axis. We want the length of EF. So he's doing well. He's finding the distance from the two coordinates, but you want the coordinates of E and the coordinates of F. And so this student is just using the exact same coordinates. E and F doesn't have the exact same coordinates. We need to find the coordinates of F. Now F is a point on the straight line. So all I need to do is find the coordinates of F. Now do I know the x value of F? Yes, because it's the same as the x value of E. The reason why they say it's perpendicular here is because they want you to know that F and E has the same x coordinates. And so we have E's x coordinate, that is 3/2. So we substitute 3/2 into our function of 3 times x plus 18. And that gives us, well, let me do that one. So we have -3 times 3/2 plus 18 gives me -9/2 plus 36/2 is equal to 27/2, which therefore is 13 and a half, and then the other one is 84. So this is then the one coordinate, 3/2 and 13 and a half. The other one, the turning point, that's E, is 3 over 2 and 81 over 4. 81 over 4 goes into 81 is 4 goes into 81 20 times. That's 20 1/4. Okay, so notice here my x values are the same and my y values go from 13.5 to 20 1/4. So just notice here that this is 13.5, that is 20 1/4. So the difference between these two is the length of EF. So from 13.5 to 20 is 6.5 plus 1/4. So 6.5 plus 1/4 is 6 3/4. Okay. Draw the sketch in your graph of a graph in your answer book with the following, where A is bigger than 0, B is smaller than 0, and C is greater than 0. The equation of that has only one solution. What a cool question. I love this question. Okay, so it's a problem solving question. Let's see what the student did. Okay, just get there. Here we go. Okay, I think what we need to recognize is what each of these values mean. So let me show you what the consequence is going to be. If A is bigger than 0, first of all, it's 4 marks. So first of all, you're going to get 1 mark for each of the properties that is affected by these values. So for example, if I have y is equal to ax squared plus bx plus c, okay, then the fact that first of all, I know it's a parabola. So it's either a parabola like this or a parabola like that. This is the value if a is bigger than 0. This is the value if a is smaller than 0. So that's the first thing, is I know that this graph is going to be this shape. The next thing they tell me, now I just want to know where is the turning point for this graph. Okay, so is the turning point for the graph on the left hand side or the right hand side of the y-axis? And how do we get that? Well, we look at the center line. Center line is negative b over 2a. Now I already know that a is positive. Next they tell me that b is negative. So a negative times a negative is a positive. Understand? So in other words, this value will be bigger than 0. So anywhere here will be my center line. Okay? They also tell me that my c value is greater than 0. So my c value greater than 0, my c is where I cut my x-intercept, my y-intercept, sorry. So I'm cutting the y-intercept somewhere at the top. So I have to go through a point here at the top. And then finally, they just tell me, so I know my turning point must be somewhere here on this line, and I must cut the graph with a shape like this. So it's either going to look like this, or like this, or let me rather do it like this, or this, or this. Those are the 3 types of graphs I can draw through there, as long as I just draw a turning point on this line going through that point. Now let's just look at the last piece of information. Ax squared plus bx plus c equal to 0 has only one solution, which means when I take my graph, I make it equal to 0, I'm finding the x-intercepts. I only have one x-intercept, and so it looks like this. Okay. And so I get 1 for cutting the y-axis above the x-axis, 1 for having my center line, my symmetry line on the positive side, 1 for the positive shape, and then also 1 for having cut the x-axis only once. So just to mark the student's work, how will it be marked? Well, he doesn't cut the x-axis, okay, so he doesn't get that mark. You're not cutting the x-axis. His turning point, I can maybe give him for the turning point because it looks as the turning point is positive. He cuts the y-axis on the positive side, that's fine, and he has the what did I say the other point goes for? The shape of the graph is positive. Yeah, so get most of his marks if he only had it cut on the x-axis, but his doesn't cut the x-axis, so he doesn't have any solutions to his that equal to 0. Okay, next question. Question 5 is still a graph question, so I'm going to continue in this video. So here, write down the equation of the inverse. So I'm hoping he gets that right. Question 5, yes, there's the inverse perfectly. This is a knowledge question, level 1. You just should be able to know that the inverse of 3 to the power of x is log base 3 to the power base 3 inside x. The next is draw a sketch of f and the inverse of f on one set of axes. Draw the graphs in your answer book, and then you see they're perfect how his two graphs look like. This is just a basic exponential graph, and then it's reflected in the y is equal to x line, basic, and what's important would be your intercept would be important. Okay, so well done student, excellent work. Next question. Write down the domain of the inverse. Okay, so we've looked in the previous one as well. This is wrong. Okay, the domain are all the possible x values, and you'll notice here you don't just have x values bigger than 1, you also have smaller than 1, but all of them are bigger than 0. The domain, and so there's 3 domain rules. I'll do them again. Theory, 3 domain rules. 1 over something, then something may not equal 0. What's the other one? Square root of something, then something must be bigger or equal to 0. And then log base of something, then this something must be bigger than 0. Now in our case it is log, in this case it's log base 3x. So it just follows that x is bigger than 0, or something is bigger than 0. I might have had log of base 3 2 minus x. Then I would have said 2 minus x must be bigger than 0, so x would be smaller than 2. Okay, if you solve for x, then you get the domain there. Okay, nevertheless, for which values of x will fx times the inverse be less than 0? That means when will this one times that one have different signs? Because if I have a positive and a negative, I'll get a positive and negative. I'll get a negative, positive and negative, or negative and positive. But this is very common, guys, and you should get it now. We've done it hundreds of times. When I have a function times another function, doesn't matter that it's the inverse, it can be any function. If it's asking me when is it less than 0, it's asking me when does the two have different signs? When is the one positive and the other one negative, or the one negative and the other one positive? For graphs, it's when is the one at the top and when is the one at the bottom. So if I go and look at his sketch, when is the one at the top and the other one at the bottom? Well, here's one at the top, but there's nothing at the bottom, so it's definitely not here. Okay, here's the one at the top and that one at the bottom. But from 1 onwards, both of them are above the x-axis. So the answer is when x is less than 1 and bigger than 0. Okay, but notice what the question says, and that's a little bit of a trick question. When is it greater or equal to 0? Now, when will something times something equal 0? When one of the two is equal to 0. So if we just look at the graph, equal to 0 means I cut the x-axis, and it only ever once cuts the x-axis, and that's at that point. So you can't just include it this time, because when x is equal to 0, if I equal 0 there, that won't work, because when I equal 0, this function isn't even defined at 0. It never gets to 0, so it can't equal 0. So definitely not that one, but definitely including 1, because at that point this function is 0. It doesn't matter what that function is, this one times that one will equal 0. At this one, but the inverse is not defined, so that's why it's not included. Write down the value of g, which is the reflection of f in the y-axis in the form. So when I reflect something in the y-axis, I give my x a negative. It's as easy as that. Okay, so that's perfect. Okay, another question given here is the graph of ax squared. The point -3 lies on the graph. Okay, find the value of a. It's literally just a substitution. Again, I've got one parameter left to solve, substitute, and so don't know why it doesn't finish it. The answer is literally -4/9. Okay. Find the inverse. No, come on. Oh man, guys, no. There's 8 points that you didn't attempt because you couldn't find a, and you got a by simply going on. No, unacceptable. Okay, well, it's no use I go on, there's no one to comment. But okay, find the inverse. Well, here's the inverse. It's -4/. Let's get that thing. Okay, here we go. We now have that y is equal to -4/9 x squared, and now it asks me to find the inverse, so I swap x and y. -4/y, over 9 y squared. Then I solve the y squared, so I've got y squared, so I try and get the y on its own. And to get rid of this, I must just divide it on that side, but for a fraction it just turns it around, so it becomes -9/4x, and then y is equal to, I take the square root on both sides, plus minus the square root of 9/4, and it's -9/4x. Now everyone says, whoa, wait a minute, you're not allowed to do that, because you're not allowed to have a negative under a square root. Guys, you don't, no, it's not allowed to simplify to a negative under square root. In other words, -9/4, x must be positive or 0. That just means that x must be negative. So of course I'm allowed to have a negative under a square root if I can still multiply it with something else. I just make sure that what I multiply with is a negative. And that's why this one's domain, the domain for this one will be that x is smaller or equal to 0. Next question, write down the domain for the inverse. That's exactly what I just did. The domain for the inverse is that x is smaller or equal to 0. So you'll notice what happens to this graph is it just looks like that. It turns, draw the graph, okay, of h of x, and so here's what it looks like. here's my original, and here's my, sorry, now I'm also not touching that. Okay, that is, and you can see this graph is a reflection of this one. So just where this one is going towards the negative y values, he's growing towards the negative y values. When I swap x and y's, I'm going to get a graph that grows towards the negative x values, and that's why it's this way around. Okay, not going to do a lot of effort there. No one else did. And then the next question is financial maths.